Hi, today's topic is linear inequations. Inequalities are solved in the same way as equalities. So, inequalities are solved in the same way as equalities. We solve the equations. Only one exception, or you may say two exceptions. One is that with exception, when we do the operation of multiplying with -1 or divide with -1, both sides, inequalities we don't need to change anything, both are equal, but here the direction of the inequality sign reverses, like inequality signs reverse, means greater than will become less than, or less than will become greater than. Suppose take an example that -6 plus 3 greater than 0. So, what we are doing, if we are multiplying here with -1, both right hand side and left hand side, what we are getting, that +6 minus 3, it should be less than 0. So, x less than 3, that would be my solution. Now, question may arise that why so. Take this number line, this is 0, then these are my positive side, right hand side is positive side, more positive numbers, and left hand side is negative numbers. So, 1, 2, 3, here it is -1, -2, -3. Now, see here 1 less than 2 less than 3 like this way, but here this is, it is -1 greater than -2 greater than -3. So, any operation, suppose we are doing here or here, that we are multiplying it by -1. Now, -1 cannot be less than -2. It is always -1 greater than -2. So, that is why we need to change the sign when we are doing this operation, that with -1 I am multiplying the both side or dividing it by both side, all the same. We need to change this inequality sign from this greater than to less than because of this reason. Now, simply take some examples, do some examples to get a better picture of what I am telling. So, this is my first example. So, how to solve this? We can see that 5 and 3 LCM is 15. So, multiplying left hand side and right hand side, both side with 15. Plus 1 into 15 by 5 minus 2 minus x into 15 by 3 greater than 3 into 15. So, cancelling out the common factor, you can write over here or you can also use this sign. So, or 6x plus 3 minus 10 plus 5x greater than 45, or 11x greater than 45 plus 7. Like the equalities, here it is -7, and when it comes to the right hand side, it is +7. So, x greater than 52 by 11. This is my solution. Take one more example. suppose a minus x by 2 plus 1 greater than a, where a is any arbitrary constant or real number, can have any value, but we have to mention the condition that a greater than 0. If a less than 0, then maybe this inequality will not be valid. So that is the condition, as we have no idea about e. So again I am multiplying it with 2 with left hand side and right hand side. I am getting or minus x greater than this thing, or minus x greater than a minus 2. Now you see, now I have to multiply it, I have to multiply it with minus 1, because I need to find it out the solution of x, not minus x. So multiplying the both side with minus 1, what is happening here? It is x is positive now. Here I am getting 2 minus a, and this sign will simply reverse, less than. This is my solution for x for this inequality. Now what I am telling, that inequalities that involve absolute values. So better write down this heading: inequalities that involve absolute values. Absolute values or the modulus values. We need to remember two conditions very well. One is modulus of x less than a. Then we have this situation, x would be in between this minus a and plus a. That we already have done it during this finding out this absolute values, how it lies. Now in number line, what has happened with this? If this is my origin 0, then a positive and a negative, I am seeing that it is not touching. So in number line, this is my, I am getting a range of values for these inequalities of absolute value, not a single value like that greater than 52 by 11 where we find this kind of solution. Not that kind of solution. There would be an entire range, a set of values. So we call it the solution set for absolute values in inequalities. And again, second condition is this: when mod of x greater than a. When this situation comes, we know that there is two subsets like that, a x less than minus a and x greater than a. And in number line we already represent that as, if a is here and minus a is here, then our solution subset would be like this way, and they will be extended to infinity in positive side and negative infinity in negative sides, that is the left hand side. So the solution would be the union of these two sets. Okay. Well, if I write that in set notation or in interval notation, it is not touching, so hollow. So what I can do, I can use a third bracket. So x belongs to minus a minus infinity union this interval sign I am giving, a positive infinity, union of these two sets. I am writing in interval notation. Well, then take some examples. So for this, first example I am taking 4x plus 2, the absolute value modulus less than 6. So this give rise to the situation of the first one, this one, that mod x less than a. So applying that same thing, I can write that minus 6 less than equal to 4x plus 2 less than equals to 6. Now I am writing it together, but I'll take it as two different inequalities simultaneously to solve this inequality. So I see that there is 2 as a common factor. So first I am cancelling out the common factor from them. So it is minus 3 less than equals to 2x plus 1 less than equals to 3. Now first solve this inequality. Then simultaneously I have to take these inequalities to solve. So okay, I am making 2 colors. So here I am having that minus 3, just taking it over here, minus 1 less than equals to 2x, or minus 4 divided by 2 less than equals to x. Again cancelling out, I am finding getting minus 2 less than equals to x. Now what's about now this thing? It is, I can see that 2x less than equal to 3 minus 1, or x less than equal to 2 by 2, cancelling out them, x less than 1. Okay, so now my solution is, I am writing it together, that it is minus 2 combining them, x less than equals to 1. Now how this fits in the number line? You can see this is my number line. So this is my 0 origin, this is my 1, and this is my minus 1, this is my minus 2. As both here it is equal sign is there, so I am drawing a solid circle and my solution set is this. I can write in interval notation that x belongs to as the touching using a third bracket, close third bracket, minus 2, 1. So this is my solution set for the inequalities. Okay, consider one more example like this way. What we are getting, my example 2 over here. Okay, modulus x by 2, 3 minus x by 2, absolute value of them greater than equals to 5. Okay, sorry, I need to take that call. Okay, so getting this example again, now this situation put us in this condition that mod x greater than a. So for that I know that x either less than minus 1a or greater than a. So I have 2 cases, 3 minus x by 2 less than equals to minus 5, and in second case 3 minus x by 2 greater than equals to 5. Now first I am solving the case 1. So I am having this minus 8 or minus x less than equals to minus 16. Now I have to find out the value for x. So multiplying both sides with minus 1, I am getting positive x, and reverting the sign is 16. So this is 1, and this solving this I am getting, or minus x by 2 greater than equals to 5 minus 3, 2, or minus x equals to 4, or again multiplying both sides with minus 1, I am having x less than equals to minus 4. So again this number line you can draw. This is 0 if I say 16. Okay, if this is 16, then 16, this would be minus 4, Now as they are touching, I am drawing as solid circle and it is extended towards positive infinity, and again it is touching -4, so solid circle and extended towards negative infinity. So this is my solution, and the solution set would be solution set. I can write like this way: x less than equals to -4 union x greater than equals to 16. Okay, same manner for interval notation, x belongs to, as it is touching, so a close third bracket -4 comma minus infinity first bracket union again closed third bracket 16 comma infinity first bracket. Okay, take up some more example where I have to deal with absolute values in both the sides. Suppose I am, this is my third example of inequalities. So let's solve this as well. The solution for this set or this inequalities. How to find it out? Now you see it is x equal to 4 minus mod x greater than absolute value of 2x or mod of 2x. Now here it is mod of 2x simply means 2 into mod x. 2 always come out as a positive value. Now taking out from this and writing the set, this inequalities, that 4 minus mod x greater than 2 mod x or 4 minus mod x greater than 2 mod x, and taking this x on the left side and -4 on the right side. What I am having? Mod x minus 2 mod x greater than -4. Simply for the equalities, the way we have done so far, it is okay. So it is -3 mod of x greater than -4. Now here, as again I am multiplying both sides with -1, then what I am having? I am having it is 3 of mod x is less than 4, or mod of x less than 4 by 3. Now what I am getting? I am getting already x less than 4 by 3. Means x less than a, what we are telling that it is should lie in between like that way, x 4 by 3, and that is my answer, my solution set. So in number line, if it is my 0, then see this is 4 by 3 positive and this is -4 by 3, and I can write this as there is no equal sign, so hollow circle, and my solution set lies in between this. Take further one more example. Here it is given x modulus 1/3 x minus 1 greater than mod of x. A similar thing I am doing, I am taking it out, and now here I am interchanging mod x, I am bringing it on the left side, and modulus of this part I am taking on the right side. So I am bringing it here and giving it there. Now simply remember, if I write 3 less than 4, but when I am interchanging I have to write 4 greater than 3, this inequality sign will change. So as I am doing it, I am writing it mod x, so less than that mod x it be less than mod of 1/3 x minus 1. So again here my first case, I can write it in a range, that closed range, a number line, that with this mod sign, of course, that minus of mod 1/3 x minus 1 is less than x, and x less than mod of 1/3 x minus 1. Now remember, this has again two values depending on if it is greater than equal to 0 or less than 0. So we have to consider those two for this modulus, as we already have done for the inequalities. So this thing has again two, it is 1/3 x minus 1 as it is when this value is greater than equals to 0. It means taking minus 1 on the right hand side and cross multiplying by 3, we are having that x greater than equal to 3. And again it is minus of 1/3 x minus 1 when this 1/3 x minus 1 less than 0 or x less than 3. Now what we have to or need to do, that if this is case 1, first we considering that x greater than equals to 3, we have to put this value in both these places, and we see what solution we are getting, so that it would be a closed range and this condition x greater than equals to 3 is also satisfied by them. Or this one also there, my case 2 where x less than 3, I have to put this value also in these two places and see what I am getting the solution or not, considering that x less than 3. So first do the case 1, then case 2. I am changing my color, my case 1 where I am considering x greater than equals to 3. Now putting that value in that closed range, what I am having minus x by 3 minus 1 less than x by 3 minus 1. Now in the same manner, what I am doing, first I am cancelling out this 3 by multiplying all with 3, and for here also for this leftmost side, the minus also I will multiply with that and open this bracket. So I am getting minus 6 plus 3 less than 3x less than x minus 3. Now first in the similar manner, I will take this as one inequality and this as another inequality and solve them. So first solving this side, so just taking this minus x plus 3 minus 3x less than 0, what I am having, minus 4x plus 3 less than 0. Now minus 4x less than minus 3, and again multiplying with minus 1 both sides, what I am having, my sign will also change, that x greater than 3 by 4. One solution. Now here I am seeing what I am getting over here. So here 3x minus x less than minus 3. So 2x less than minus 3. So x less than minus 3 by 2. Now look at this two thing very carefully. I am telling that my condition should match that x greater than equals to 3. For this solution it is not matching, and for this, okay, this is also not greater than 3. And what I am expecting, a close thing, means there would be the number line 0 my solution would lie in between like this way, a finite solution. But here I am getting infinite there, and it would be union of two subsets. So this solution for case 1, there is no solution for the inequality. So I have to switch to my second case, just changing it the color. So in case 2, what I am getting, that x less than 3. Now considering x less than 3, I am putting the values of modulus of 1/3 x minus 1, that negative value I am considering now. So minus 3 it was minus actually plus 1, yeah, less than x less than minus x by 3 plus 1. The same thing I am multiplying with 3 and here minus 1 as well. What I am getting, x minus 3 less than 3x less than minus x plus 3. The same manner I am just for solving this. What I am getting x minus 3x less than 3. So minus 2x less than 3, or again multiplying with minus 1 both the sides, I am having x greater than minus 3 by 2. And here it is considering these inequalities, I am having 3x plus x less than 3, or x less than 3 by 4. Directly I am writing it. Okay, so here I am seeing that my condition is x should be less than 3. Yes, in both the cases the answer is true. And in the number line, if this is my origin and this is my 3/4, if this is 3/4, then this would be my 3 by 2 negative. Here it is negative number. So it is my solution set lying in between these. So this is my solution. My solution set is, for the given inequalities, is x. First I am writing this is 3 by 4 and minus 3 by 2. So x lie in between this. So this is my solution. Thank you very much for following me, and I hope you are also practicing, and this is a useful lesson for you. If you have any question, please send a comment. I'll try to answer it as soon as possible. Thank you very much.